And ooh, good evening, good afternoon, good morning, everybody. Welcome on into the Dragon's Den. How's everybody doing today? Hey, Mr. Wizix, got your shirt and sticker today. Awesome, awesome. How you liking it? The shirts that you get through Stream Elements, which is Zombie Hedgehog makes one, is the same thing through Stream Elements. They are pretty nice. They're soft. The silk screen doesn't seem like it. Like sometimes you get silk screening and it feels like it's really thick and heavy and adds structure to the shirt. And these don't do that, which I like. Welcome on in, Tugboat. How are you doing? I actually have a box sitting right over here ready to go. I just need to run through it, double check everything that I'm sending out, and then get it into the mail. So shirt and the print, yeah, nice, nice. You like trains? Yeah. So I'm wearing a hedgehog make shirt and drinking out of a Tesla's mug. So I've got Z and Z on the mind. How you doing tonight, Zombie? Could say today, this evening. I guess you are East Coast. I don't know why, for the life of me, I keep thinking you're West Coast. But welcome on in, everybody. Welcome on in. Building trains. Gotcha. Gotcha. So I did have, and I know this is going to be really weird sounding thing, but I did have some packages arrive today. Did you stay up past 1 a.m.? Yeah, well, I do too, but I just don't stream that late. Also got a zombie shed set of shirt and sticker today. Good. Well, that's interesting, Mr. Wizix. They didn't get the actual address, so they sent it to your city with no address. That's weird. That's weird. So I got in a few things in the mail, and I know everybody's just like flabbergasted with that idea. But let's see, from KB3D, my two Slice Engineering vanadium nozzles. And it is a, what do we have? We have a 0.5 on this side and a 0.6 on this side, along with one of the cool stickers you get if you add the sticker to your item. You'll get one of these cool stickers that was it. I made this thing with parts from KB3D in support of Digital Dragon. And I believe there's one just like this, maybe some slightly different colors with Zombie Hedgehog on it. But yeah, I decided I wanted to get a couple of different nozzles to try. So I've got a 0.5 and a 0.6. These are the vanadium nozzles from Slice Engineering. So hardened nozzles from Slice. And then, of course, I want to say, is this a 0.5 and a 0.6, or did I get 0.6 and 0.6? And, so 0.4 and 0.6, these are Undertaker nozzles from West 3D. So, yes, Zombie, I will be putting an Undertaker on the Goliath. Will be doing it. And then there is the torque wrench that I got. You know, once again, it kind of looks a lot like the Slice Engineering one, but it does say that it's for 1.4 Newton meters, which is going to be hard to see there. But it does say that this is 1.4 Newton meters, and it comes with 3 different size sockets. So we have a 6, a 7, and a 8mm socket. So there we go. We have the nozzles. We have the torque wrench to install the nozzles with. Got some more West 3D stickers and the Undertaker sticker. Talks about the mythology of the Undertaker nozzles, I'll say. And then we also picked up some Peck's pepper sauce. Now this is stuff that I got off of during your stream, your birthday stream, Zombie. And of course, I want to say I ordered it, and then they came out with the. I ordered, and then they came out with the larger percentage off. So that torque wrench is from West 3D. So KB3D only sells the Slice Engineering, which is 1.5. West 3D had the BQ Crab torque wrench, but it doesn't list the torque rating on it anywhere in the literature. And then that one I want to say is the Triangle Lab ones through West 3D. And you can get it in 1.4, I think it was 2.2 and 2.4 on those torque wrenches. So, but I picked up the Pueblo Red Peck's pepper and the Revenge Barbecue, which is a smoky habanero apple barbecue. So I did pick up a couple. I got one of the little samplers that they were giving out at Rocky Mountain, and I'm like using that like mad on everything. It's pretty good. So I used to do like all kinds of like heavy spice. So I would go to like Hooters and get the 3 Mile Island wings and go over to BW or B-Dubs, Buffalo Wild Wings, and get the hottest wings they have. And ever since I had my gastric bypass surgery, I just can't do the super hot stuff anymore. Hey, Pez Liz, how are you doing? So I'm drinking from the mug of Liz and wearing the shirt of the zombie. So I've got Z and Z on my mind. And real fast, before I do a KB3D Chris, I've got my soldering iron warmed up here. I was trying to sneak these in before stream and did not make it. But I'm trying to prep a couple of parts real fast for stream. And honestly, I can never remember if these were designed for heat sets or not. But I tend to put heat sets in them regardless. But these are going to be printed. These are 3D printed Denrail spring clips. Because we will be starting the install of the electronics on the VzBot build today. And don't do what I did and just grab hold of the part that you just installed. A little hot. Building a Zero next. What do you mean? Will I be rebuilding my V0? I mean, it's something that I've been talking about. I've got the stuff to do the upgrade to the 02. I just need to print the additional parts. Oh, the new stealth press. I don't know. I hadn't thought about it. Partly because I've got another project that shows up tomorrow. But is a project that I will have to hold off on until after Murph. And that is my my Milo is showing up tomorrow. Apparently it's 3 boxes. I think the standard Milo kit is 2 boxes. And I've also got the, it's batch 2, so it's got the 110 volt, twisty turny thing to it. God. English sometimes. Spindle. So I got the 110 spindle with it. I guess it helps if I actually make sure that that starts printing. Hold that thought. That's not what I wanted anyhow. You ever do that, zombie, where you're like, okay, I need to print this file, and then you hit print on the wrong file? I do. I do that occasionally. So today we're going to be working on the VzBot, and we're going to be working on the electronics. So that's kind of why you see some Mellow boxes out here. We've got some parts here that we're going to use for our 5 volt, 24 volt, and 48 volt. Still need to do the one for the mains power, which will be ground, load, and neutral. And that's the one I'm getting ready to print right now. We're going to need some other printed parts, such as our mounting plate here for our Mellow Fly controller and the external 5160 drivers. There was a part of me that was trying to decide, do I really want to go with the Mellow and the complexity of all the wiring that it entails, or do I want to throw the Kraken in here? Especially after seeing Nero doing the conversion over to Kraken. And I think I've decided that, yeah, I want to go ahead and use this the way the kit comes and leave the Kraken maybe for a yet to be decided or defined project. Because there are thoughts that I'm having of other projects that'll be coming to the channel. So what we're going to do is a little bit of prep work just to get some things mounted, and then we'll bring the printer up and I'll show you a couple of the things that I did off stream. And yes, I did do a few things off the stream because it really, I'll say it worked out a little bit easier. It was drilling into the back panel, but I'll go over that and I'll show you how I did it and everything. And I'm going to use M3. I was going to use M3x8s because that's what Steve and Daniel did, but I'm actually going to go over and use the M3x6s. If I need to, I can fill in button heads out of my own stock. What we're going to need to do is get our motherboard out, get that mounted, and then we're going to have a potential of a lot of wiring to do once we get things all situated and mounted. How are you doing tonight, Tin Talon? Pez, what are you up to these days? Other than, of course, the Z and Z. So we need to go ahead and mount these to the back panel here. Just trying to decide which order I want, or which direction I want to put it in. And it looks like, because of how this mounts, it's going to mount in this orientation, which means I want to be able to take my clips and go up with the bottom part that snaps in underneath. So that's the way that clip would be oriented. We're going to put these in there like that, and it looks like this uses M3 screws and some M3 nuts. So printing some rep racks. That's really cool. I think several of us have done those here on streams. That's pretty good. Always fun. Okay, so for these mounts, I'm probably going to have to use the M3x8s to do the den mounts. When we mount the actual electronics, we're going to use M3x6s. And when we go to do the mount the boards, it's all done with just direct screw in. So there's not going to be heat set inserts into this mount. And that's simply because it's getting mounted and backing up onto a metal back panel. And that metal back panel is going to be grounded. But just to prevent any shorts or any other additional grounds, we want to make sure that we keep a common ground and we don't have multiple ground points. Because that would induce noise in the system, which is normally bad in electronics. But yeah, I understand you on the rep racks. I've got a whole closet full of them. Feel like I need even more. So the depressions, and that's about the best thing I can call them, is depressions of the, it's like a hint. Yeah. It's like the hint of a nut holder there. Really not depressed that much at all. It really should be a deeper depression for the nuts to go in. So you're not going to really be able to put much behind these when you screw them in, because they just sit there and turn. Get our DIN mounts on there. We'll mount our board. And this is going to be a little bit of a complication, or I was going to say it's a little bit of a complicated, hey Solar 3DP, welcome on in. A little bit of complicated wiring, but I'll say that, and then I start thinking back to the Annex Engineering K3. And it really isn't that much of a complicated wiring scheme when you think of it that way, because there we're using multiple boards, multiple voltages. It was just overall a more complicated build than what we face with this build. But okay, so we've got that done, and we've got our Mellow Fly board, and we're going to be looking at several pieces of documentation today on how to set up the jumpers and everything on this board. I'm relatively new to Mellow Fly, and my understanding with the Mellow Fly stuff is you can run Clipper or RepRap firmware on these boards. So you ordered did you order a 5M or the Adventurer 5M, Zombie? Which version? Yeah, the X1C, so it was time to get the P1S. Nice. Yeah, I've got an X1C over here, and so far I've had a few issues with filament breaking and a piece staying stuck in the extruder, which means you gotta lift up the AMS, take the top off, put the AMS to the side, pull the PTFE tube, stick something down in there to push that filament down and into the hot end so you can clear the sensor, put the tube back in, put the glass panel back up and everything, and it's a joy. Joy. I figured out how to do it without having an ABS multicolor print fail, but it is a bit finicky sometimes. I mean, it's printed well. I think the issue that I'm having has been rewinding filament onto a Bamboo Lab spool. And then as it gets to the end, it pulls the spool up enough that it's just engaging the one roller, and it puts too much pressure on or too much strain on the filament, and the filament gets brittle and breaks in several different places. $85M, got the Pro, but wanted to check out the regular. Okay, cool. And as I said, we are we are tapping this directly into the plastic. So you don't want to hugga-dugga the crap out of it. You just want to go until you feel the, like you can feel that screw snug up, and you don't want to take it past that, because you could strip out the plastic and then you wind up having to do a bunch of other things like pull the screw out, either epoxy or you can either epoxy in or do CA glue and try and harden that plastic so you can recut threads, or just print all new parts. So I printed one of those, and it's got batteries in it, and I have absolutely no idea where in this house it is at. I swear to God, I printed one. It's got like 6 batteries in it, and I don't know what the hell I did with it. It went poof. Like, I don't know if I threw it away on accident or what. Hey, RFS 3D, welcome on in. It's over there. Yeah, it's somewhere. Dude, I have looked downstairs. I have looked all over this office. I've been looking underneath things. I don't know where. It is a mystery to me at this point. Yeah, it's because we were just talking about the bamboo, but right now I've got the bamboo going, the K3's going, printing a part in polycarbonate carbon fiber, and that part will be another version of this. This is printed in Polymaker Galaxy Black ABS. And yes, it is a fan duct. It is a fan duct that is made to go on this. It does have a provision for beacon to be added to the bottom. And get both fans there. These are 3628 fans. So you get both fans there. And I guess it helps if I turn this the right direction. There we go. They'll be mounted like that, and right in the center would go a tube. So I decided that I'm going to print this out of the PC carbon fiber versus just the ABS. But it can take a Sherpa. This one is the Sherpa Mini mount, and I have a metal Sherpa Mini that I was going to put on it. But there is also a different mounting plate that you can use for an LGX or the FXD extruder. So that is the hot end. Well, this is the Calamity tool head mount for the tube from Luke's Lab. And that's going to be the designed hot end mount that I will use to mount tube, and tube can go on Picavoron. So is it a new printer you are building? Well, maybe. So we've got the VzBot here we're working on today. Black box is over here in the corner. Black box is ready to go. All I need to do is put the left side panel on it, and we'll be ready for commissioning. So software and commissioning will start on that on Saturday. So we're making good progress on that. Might take us a little bit, but we are making good progress. So we've got our Mellow Fly board initially mounted now. There's going to be a couple of things that we need to do. And the fun thing is, let me switch over here. Oh, well, that was perfect. Browser mode, all app, properties. Let's go here. Okay. Says this is a general overview of the parts recommended for a VzBot build. Everyone is free to use their own choice of parts. That's always nice to know. And I say that kind of tongue in cheek because this is the totality of the electronics build section. Right? Free LED strip. Those are going to be starting to print next. Mainboard. Big Tree Tech Pi TFT50. That will be the display that we're going to install. A 24 volt and a 48 volt PSU, which it says is optional. It is to me. Wires, choose the correct gauge. C14 power switch and a power cord. Talks about the all-wheel drive stuff. You can take best advantage of having 4 motors on XYs. It's to run each motor on individual stepper drivers, which would be these 4 external 5160s. Came in the kit. Both Clipper and RepRap firmware fortunately now natively support Quad XY. So you'll have to download and install your favorite firmware as described in their respective guides. For Clipper, it's recommended to use the provided config files as base or inspiration to make a configuration to suit your own build. And then it goes into more physical installs. So, yeah, that's the totality of the electronics there. Because then you get into side panels and mounting the RCS, which these mount to the side panel. Hey, Glendon, welcome on in. So then one could go to a website. That website, which I finally found and realized through watching Steve Builds and ModBot's build, is here. And this is docs.vzbot.org. Okay? docs.vzbot.org. And if we come out here to the main screen, it has documentation for the VzBot 330 printed or the Mellow kit, or VzBot 235 printed or the Mellow kit. Well, we've been building the Mellow kit, so I can click on that. And we could go down through here and look at like the Z in the bed, the gantry. This would have been good to actually realize. Bottom rear panels, fume extractor, electronics. Well, hey, this is looking better. It has a better view. It shows some of the trim pieces. It shows the gen rail in here, a Raspberry Pi. There's a board missing. It shows the fans, so that's kind of interesting. Same loadout, same STLs, and then a video. So that's it. We're going to build our electronics by watching the videos. So yeah, that's what we're going to do here. So let me scoot that over. No. So this board here, the Mellow Fly 8, this is really close to an octopus. right? Your Octopus is going to have 8 drivers. The difference here is, I believe, the first 3 drivers, so 0, 1, and 2, are 24 volt only. 3 through 8, so the last 5 drivers, can be high voltage. Okay? And that's based on what you put in here. So you've got, let me grab the sticker. So in essence, what we have here is bed output, bed input power, power input for the board, drive power high, drive power low. So the low is the first 3, so 0, 1, and 2. The high input is the last 5, supposedly. So to make sure that we get this configured right, we are going to have to look through the board here and actually talk about it. I don't want to kind of go through the intro, the layout, the design and stuff, design and print, because that gets like the first 10 minutes of the video. What I'd rather do is get into the parts of the video that we really need, which is really how to properly do the electronics. And quite honestly, I could probably also bring up, did I download it? Oh, give me 1 second. So there is a wiring guide for the VzBot. I just need to see if I actually download it. And that looks like a big fat maybe. Give me half a second here. That wasn't actual. Okay, so my bad. Apparently I need to come up here, and is there a wiring or wiring diagram? Yeah, please note, important, always connect both power supply DC negative together so they have the same reference ground. We will be doing that. For 48 volt step 6 drivers, the Super 8 has 2 separate bank of drivers, 0 to 2 and 3 to 7. You want to run your Z and E on 24 volt and XY on 48 volt. You have to use 24 volt on port 0 to 2. Place your 48 volt on port 3 to 7 for the step 6 drivers. What are you doing? Use the external 5160 for Mellow, then you can use port that you want to feed 24 on both driver banks, then supply 48 volt only to the external drivers directly, which is how we will do this. Blah, 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 blah. So this is how we're going to basically do our layout. We're going to have one full length din rail, another one down near the bottom portion. And on this bottom portion, we'll have our mains in on the bottom left with our SSR. So the bottom left quadrant will be all of our mains voltage. Of course, with the power line running over here to supply mains to this PSU. And then on the bottom right quadrant over here will be all of our DC voltage. This will be any 5 volt, 24 volt, 48 volt breakout over here. Have our main board. We'll have the 4 external 5160 drivers that sit underneath the fans. And then this actually shows the controller board for the CPAP. Just basically gets on a mount and VHB to the back of one of the power. Okay. But this is kind of where we're at. The kind of gives you a little bit more of an idea of what we'll be looking at here as far as lighting and everything goes and how we'll lay it out. Hoping download, see if I can. There we go. Huh. That sucks. I was hoping they would show the jumpers on here, not, or the for the actual driver spots. So we're going to have to look at the board or look at the video for figuring out our actual jumpers. Go back over here. We'll look at the main board part of this. Din rail. Can you guys hear the audio of the video? Not sure if I actually pushed that audio through or not. Does mount all the fans. Oh, there's Pezlas again. Hey, Abadus, how are you doing all? Or how are you doing? So we're just trying to set up all of our different electronics pieces and make sure that we get everything in here and set up. I think what I'm going to do now, I've got the main board. I'm going to go ahead and put the drivers in place with their heat sinks so we can just kind of start building some things up. We'll come back and it will talk about adding the fuses and stuff like that. There's 4 different blade fuses. We've got 10 amp and 15 amp fuses. So we'll have to install these. These are for the main motherboard. But let me go ahead and just get these boards out. And this is where he was talking about our heat sinks. And these heat sinks are going to go across these 8 small driver boards down here. to try and cool these down. So we're going to be on there like that. Because this would be the 5160 itself, and then the small pack of 8 are the actual MOSFETs that are dispersing the no audio from that video. Okay, need to figure out there. So I believe I just turned on the output option, so let me just kind of double check. And now are you guys getting audio from this? Still no audio. Interesting. I wonder if it's a setting that needs to be done like outside of an active stream. Oh, there we go. That would be one. That's what I. Are you guys hearing it now? Still no. Okay, well, I have tried. I'm going to go ahead and just try and get caught up with them. I'm going to mount the heat sinks here. Like I said, my goal is to cover up the MOSFETs on the board. I'm going to do this to each one. Yeah, I tried to I tried to add it. I don't know why didn't. Anyhow, once again, what we're doing is we just have those 8 MOSFETs there. I'm going to put this over the MOSFETs to help dissipate the heat off the MOSFETs. Okay. And it's nice that we have silk screening, but I wish the silk screening was visible. So see we've got VCC, ground, and then our 4-pin or our 4 wires for our motor. So just be aware of that. We'll come back to that in a little bit. Okay, now I know what these. Anyhow, what we're going to do is we're going to mount the heat sinks to our 5160s, and then we'll get those mounted up onto the board, and we're just going to kind of continue to build this board up. Ah. So this is going to be a little more complicated of an electronics build, just because of the external drivers and some of the cabling that we're going to have to do for that. Especially when we start looking at these drivers are SPI. So our connections between the 4 drivers to these boards is going to be an SPI connection. And then from I'm going to need to install these one at a time, and these are probably going to have to be M3x8s because I'm not going to have enough M3x6s. So, English, yes, English. So the connections for 4 of these over these drivers are going to be via SPI, and then the main our main drivers for Z and E will be TMC2209s, I believe, going UART. So and you'll notice when I put the ends in, I'm only doing the 2 internal edges. And that's because when I go to put the fan cover on, it will go all the way through the 2 all the way at the end. And we're just going to use really, really long screws. When we do this, we need our screw down terminal inputs to be on the side, because that's what's going to give us the access to install the wiring for our actual stepper motors. Yeah, as we were talking about before, I did get some Pex Peppers hot sauce in that I bought during a Zombie Hedgehog stream. And the Polymaker filament that I bought during that stream came in as well. I picked up 2 of the metallic blue ABS. The other ones, the Polysonic purple and orange, and a couple of spools of PA612 carbon fiber, which, believe it or not, is going to come in handy for a, I'll say, a commission that I just got in for a part for someone's ski boat that needs to be replaced. Yes, Hex Peppers. I've been using the little, the little sample version that they gave us at Rocky Mountain Rep Rap Festival, and it's really, really good. It's really tasty. And I picked up the, we got Pueblo Red, which is the roasted red Pueblo chili hot sauce, and the Revenge Barbecue, which is smoky habanero apple barbecue sauce. I figured these 2 would be pretty good to start with. Who knows? I'll keep trying them. I know that they've got the, what is that, like a chef's bundle or something like that, that had 13, was it 13 different sauces in it? The little trial sizes or the small size bottles. My problem is Mrs. Dragon doesn't like hot stuff, and neither does anybody else in my family. So I'm like the only one that likes it. So I got to be careful how much I get, because it's just going to be me eating it. 12, okay. So it's an actual dozen instead of a baker's dozen. Because a baker's dozen is 13, because you always have to have one for the baker to try and verify that it was, the recipe was good. West 3D is pretty mild. Okay. Like I said, I don't mind hot stuff, but ever since my gastric bypass, my stomach tends to have more issues with the hot stuff. And it yells at me sometimes, not that I listen. Or I listen at that time and I forget. Hot sauce is not bread. That is true. That is true. But I like to grow like cayenne peppers, and I did habanero peppers one year, and I did poblanos. Smoked poblanos are amazing. If you smoke them or barbecue them and basically roast them over an open flame, and then grind them up and use them in sauces. Going in for the drop. Okay. I can tell you right now, this thing's getting kind of chonky. So there's a whole lot of electronics there. Now you were talking about a Kraken. Let me show you a little bit of a comparison. As we showed before, this is the Leviathan board. Okay, so you've got the 5 standard drivers, so like 4Z and the extruder driver for your 2.4 or a Trident, and then A and B drivers that can take the higher voltage. So if we lay that on top of the Fly, it's pretty close. It covers things up, right? This feels wider. It's probably wider a little bit. Like I think an octopus is more like this versus this. But it's adding these external drivers that adds a lot of weight and heft to this board. And then Kraken dwarfs this. Kraken makes this look like a toy. And I would grab Kraken. It's just buried over here under a bunch of other stuff. Yeah, Chonky Boy motherboard. Exactly. So he is showing installing the drivers. His order of operation here is kind of scattershot as well, because I wouldn't bother putting this on until I do all the wiring between the board and the extensions. Now I can go ahead and mount the fans on the board here. So let me grab the 4 fans, which I think are in one of these. So we've got 4 fans here, and these are 12-volt fans. Now why these fans were not provided as 24 volt, since we're pretty much using 24 volt and 48 volt PSUs, I don't know. There's no cost difference between a 12 volt and a 24 volt 3010 fan. I'm going to use these because while I have some 3010 fans, this would basically force me to convert all of my 24s to, my bench stock of 24s into 12s. Now I believe this board has separate MOSFETs for the fan inputs, and you can voltage select based on jumpers. So, and I'm not sure, these are 3010s, so we probably want to use 3010s with countersunk or countersinks. So we probably want to use 10 millimeter screws for these, because once again, we're screwing into plastic and not that thick. It doesn't do us any good to go through this and have metal parts sticking beneath it. I'm going to want all 4 of my fan wires to be coming out the inside. Get this lined up, 3x10. So the button heads, these fans have little cutouts to put like M3 nuts in them. So the button heads will go down in there. You just have to give them a little bit of force because button heads are a little bit wider than, say, standard hex head sockets, which I don't think we have. Yeah, not in quantity. I mean, I've got plenty of them over here, but we'll continue to use our button heads here. Hey, Timur, welcome on in. How are you today, my friend? I feel like this is not lining up on my part 100%. Oh, you turned 84 today. Holy cow. That is crazy, my dude. Glad to see that you're still enjoying our hobby and staying active and all that good jazz. Hey, Pez, have you been keeping an eye on Westery? Make sure she stopped stabbing bags? Or is she still stabbing bags open? And Zombie, how goes the Doron Velta build? Lasts a long time? I can understand that. That due to some self-pickling or what? Hey, Rodney Mack, how's it going? And Liz, I could almost see the look on your face last night when Royal Nomi kept popping her, was it sour pickleballs? You're sitting there eating them sour pickleballs straight. All right, good. You got some more rolling T-nuts? Nice. Yeah, I normally keep 3 and 5s on hand. Yeah, definitely. Happy birthday, Timor. I would sing, but that's not a present for anybody. That is definitely not a present for anybody. I hate trying to build by video, but that's what we've got. Now we're going to put the DIN adapter on, which means we need to take the board back off. Okay. So here, once again, he's installing the steppers, but he hasn't done the jumpers underneath the steppers yet. Just testing out and test fitting things. Now he's talking about the fuses that we're going to need to install. So the 10 goes in the slot right over here by the 0. Whatchamacallit? And then the 15 amps go everywhere else. So one here. So what he's talking about now is the ones for the 5160s are SPI. And of course we get an ad. And so we've got our jumpers. And for our SPI mode, it's all 4 of the slots get a jump, or all 4 of the slots. All 4 of the things get jumpers. So might grab some different jumpers like these. So These jumpers right here are great. They've got this little tab, which is fantastic, unless you're putting something over the top of it. Then it's not fantastic, because if I put this on here, right, that tab makes it easier to get off, but that tab is just proud, it's kind of hard to see, of the plugs. So that tab gets in the way if you're not careful. So what I think I'm going to do is grab some jumpers from a Big Tree Tech board and use those. Oh, I've got 3, 4, and 5 millimeter hammerheads, but I despise hammerhead nuts. I really do. So if I don't have to use a hammerhead, I definitely will not use a hammerhead. So to put these things in SPI mode, and I'm trying to get this on here, and I'm realizing that that's not going to work either, because the size of this board is going to require me to use those other jumpers. So hopefully, if they need to, they'll just kind of bend over, and if not, then we may have to take them off and flip them a little bit. But on our first 4, or the last 4 drivers over here, we need to put all 4 jumpers on, and I'll show you here in a second what I'm setting up. As I get done dropping these. So what we're doing is the 4 at the bottom. So there's 4 three rows of 4 columns here. We're doing jumpers at the bottom 2 all the way across. So 4 jumpers going across the middle and the bottom row on 4 of these drivers. We're going to go 7, 6, 5, and 4. You just had 2 jumbo bean burritos and hot sauce. Oh my goodness. Oh my goodness. Yeah, right before stream, Mrs. Dragon said, I've been watching Applebee's commercials all day long. I want Applebee's. Do you want anything? I'm like, well, sure, if you're going to go out and get Applebee's. So she went ahead and ordered, ran out and got it. And then for whatever reason, between the time she left the house and the time she got to Applebee's, the order had been like rejected or canceled or whatever. And she had to basically redo it at the store. So needless to say, she was a little late getting back. So just for me, and in case I need to, I'm going to do driver 3 the same way. That way, if any one of the other 4 drivers has an issue, I can immediately just swap over, and the last high voltage driver is set and ready. And then same thing for 0, 1, and 2. They're all going to be set up the same way. And this is a pretty standard config for, actually for both of these, for SPI and for TMC2209s in UART mode. I'll get this set up and then I'll try and bring it over and show you guys. Show you all. So for SPI, we do all 4 jumpers on the bottom row. For UART, we skip the first row, we put a jumper on the second, or first column, we put a jumper on the second column. Once again, the middle and the bottom row. And then that's the only jumper that gets put on. So these first 3 are set up for UART. The last 5 are set up for SPI mode. So let me get all these jumpers put back in their respective bags. So we need them. Okay, well actually I'll leave these out for just a minute. For our SPIs, we're going to come back in here and we're going to grab the little driver module. Now this driver module, as he was saying, has a row of black pins and a row of blue pins. So that means you line it up just the same way. So blue with blue, black with black. We're just going to go through and set those up. Hey, Darth Gollum, how are you doing, friendo? Hope everything's going well with you. So we are building up our electronics for the VzBot, trying to get as much as we can lined up and installed on the board prior to putting the board on the actual printer. Okay, so there's our four external 5160 driver interfaces. We will have some 2209s once again for the Z motor and the E motor. These are the Fly TMC2209 boards. They are the TMC2209 boards. They look very much like the Big Tree Tech ones. Imagine that. Same setup. We're going to put a heatsink on them. And once again, the first three here are set up in UART mode. The last five are set up in SPI mode. Now, these drivers are interesting. They have a dip switch down here. You would change if you were going to use sensorless homing. Awesome, Darth Golem. I'm glad you're doing better now that you're here. I do not plan on doing sensorless homing. Plan on doing hard end stops. So we're going to have to check that out. And he jumps around. So what he's talking about now is what I kind of alluded to before is there are separate MOSFET boards. This is two. You just need to snap them apart on the snap line. So we've got two little MOSFETs here. And these are used to provide power, not provide power, but to regulate the power on our fans. Now there's 5 that are needed. There's 6 of these MOSFETs that come in the kit. He says he doesn't believe there's a polarity in the way that they are installed. However, I'm actually gonna, at this point, just try to go out and look at the Mellow board diagram. And of course, for about 20 minutes on that. Oh, and this one doesn't have the do that. I'm going to hit stop. Come over to the other instructions because I thought somewhere. My mistake. I thought there was a link out to the Mellow site for the board, and there isn't. So what I want to do is Mellow 3D GitHub. You go out to their GitHub pages. And then what we want to look at is their, what is this? The Fly Super 8 Pro board. We'll go to the repositories and we'll just look through the repositories for the Fly Super 8 board Pro. And I saw Super 8 go by already. I just wanted to see if there was a Super 8 Pro, which there is a separate Super 8 Pro repo. Clipper information, RepRap firmware information, buy it on AliExpress, Clipper for RepRap, go here, hardware. And a schematic, no. So I'm actually, okay. Like I'm surprised there's not like a manual for this board. English. Hey, there we go. Product introduction, firmware, read the motherboard ID. Yeah, so 3 through 7, 0 through 2, board heater, fan power, bed power, upper motor wiring, motherboard jumper driving. Here we go, normal jumper mode. All the ones at the top. UART mode, SPI mode, that's what we set. No driver voltage selection. Okay, the fly driver. If you do not use infinite zero return function, please turn the dip switch to the one position. On the contrary, want the infinite zero return. What does that mean? Aye, aye, aye. Fan wire. Okay, so what I'm trying to do is just find the orientation, and I'm just going to match the orientation there where it shows in the picture that the little tiny MOSFET on the chip should be facing towards the JST pins. So there's 5 of these. They basically just go into the 6-pin connector between the sets of jumpers that would set the voltage. There's 2, here's the rest. And like I said, we'll have one of these that's left over as a spare that we can use if we blow one of these, or if it fails over time due to duty cycles. That's what our little plug-in MOSFETs will look like. Teslas and K2 designs all on the sites. Yep. Once again, we have a spare MOSFET. We're just going to put that back in our bag. I guess we're going to have to go back and follow his guidance here. What I'm really trying to figure out is whether or not I need to do a dip switch on these. Oh, I'm sorry, I didn't realize that was a question of whether he's on all sites. Yes, he is pretty much on all sites, but I think Maker World is where most of his stuff is going first these days. Yeah, mine doesn't come with the Wi-Fi antenna. The Wi-Fi antenna would be if we were going to use this as a RepRap firmware board and use the integrated host controller for RepRap. All right, I'm waiting just a second to try and. This is the piece I was looking for right here. Is he's talking about the dip switch on the back here. Okay. So these are set by default from the factory with the dip switch in the off position. And with it in the off position, you can use physical end stops. If you wanted to use sensorless homing, then you would move the dip switch to the on position, and you would set up to be using sensorless homing. Now, one of these is going to be the E, the other is going to be for the Z drive. And the nice thing with that is we will be using a physical switch on Z, and with it being set the way it is, we may even have the option of putting a filament sensor on our extruder and using the end stop for whichever port we decide to use for our extruder as the filament sensor switch. So here's where we are. We've got 4 boards set up on the left side. This is 7, 6, 5, and 4. These will be set up for the X and Y and going over to our 5160 standalone drivers. And then 0 and 1 would be set for our TMC 2209s, which would be used for our Z and extruder in one order or another. Now, you were seeing he was using like physical jumper wires. Mine's coming with these FPC cables, but also has some JST pins. So I'm a bit confused on, because there are no JST connectors. There's just FPV cables, and there's FPV cables here. So these are probably newer versions of the 5160 boards. The 1.5. So we're going to need to look at these boards and see so once again, we'll come back to the repositories and we're going to look for the 5160s. And hey, Shenanigans, welcome on in. Quivering Century, thank you for the follow. Welcome in, my friend. Sorry about that. How are you doing today, Shenanigans? Actually, I was on your stream earlier today. Oh, interesting. That's it. Flipper, Fly TFT. Fly TMC5160. I'm doing pretty good. We're just trying to get these set up. And it's just getting interesting because we're trying to find information on the on these driver boards to make sure that we connect them in properly. External 1, external 1.2. So the boards that I have are TMC 5160 version 1.5 board. These are just schematic. Let me okay. Main boards, expansion boards, stepper drivers, 5160 external driver overview. See, this is showing a version 1.2 with the actual pinned cables. SPI jumpers are set, so we're using these in SPI mode. Okay, yeah, I'm kind of at a loss here. Hopefully these cables will, either there's two cables in here or, okay, there are two cables. So it looks like each one of these is going to take two cables, a thick one and a thin one. Let me try and get one of these set up, and then I will kind of show you how it goes after I figure it out myself. So the pin side is the tan side of the connector, and the dark brown side is the locking mechanism. So you want your pins on your cable to be facing this connector when you insert it, then lock it down. And it's kind of, with the way they wrapped it, it kind of works out so that if you put them in a specific way, the curve will kind of be going in the right direction. But now these are going to be fiddly with big fingers, so. You want to make sure that the cables are seated all the way down in there and that they are properly locked in and that they're aligned. So what I try and do is get my cable down in there and then just kind of shake it back and forth. And that will make sure that it gets seated down in there fully. and is properly aligned. That's kind of how these are going to go. Then we'll fold these out of the way as best we can. They're sort of fiddly when you, I mean, this is great if you spread them out in a different order or orientation. Having them this close, like as I'm going from here down to here, hopefully they'll be long enough to get there. Otherwise, one of the things that we could do would be to actually, it would almost be nice with the way these are to, I don't know what I'm trying to say here. You know, if we had them spread out some so that the, kind of take this and move it up some and spread it out as if this was a separate board, I think would make some of the routing a little bit easier between here. Because the way they're on here now, it would almost be easier to take the, take them all back off, get these cables reconnected, while they're off and just sitting side by side on the table. So I think that would give you better access to all of these little fiddly FPC connectors. Especially when you start getting in here with big fingers, like, I know this is why we have child labor laws, but children's fingers right now, small hands and stuff, would be grateful. So this is the Mellow Fly Super 8 board, the Super 8 Pro, and we're using external 5160 drivers. So if you were doing the same thing with, say, the Big Tree Tech boards and the Big Tree Tech external 5160 drivers, you would be going through the same type of process. And the older versions of these boards, these step stick drivers here, used an actual like wired cable, and it added a lot of bulk for the connection between these. Once again, with the way it's spaced, there's no real way to route these cleanly so that they're not just popping up everywhere like this. But it is what it is. We'll work our way through it. Now there are little JST connectors on here. I think that's where the fans are going to go. So maybe those 12-volt fans are powered directly off these boards. I need to double check that. That would be really good if it is, because that would be one less thing that we have to take fully across the board. So yeah, this would be similar type setup if you were doing the external 5160s for Big Tree Tech. You'd still have to have some type of step stick board to play liaison between the external driver and the motherboard. That's really just sending the signaling. It's like, think of it like doing an SSR for a mains voltage heated bed. You still have to have some type of cable between your motherboard and the SSR to communicate and tell it to turn on and off, or to allow the flow or not. So basically what we're setting up right now. And what we'll do is we're going to be providing power and ground directly to each one of these external driver boards. And we'll be providing so 48 volts is going to be coming in here on these two end ones. And then our 4 motor wires are going to actually get screwed down on these these 4 on the left. So that's basically what we're going to do. Is it's very much like if you're using, what is it, something 6600 driver on like a CNC, which is a big, looks like a cassette style external driver that you would screw down and mount to a board, or to either a board or a panel, and then you're providing your signal, your enable pin, your power, and all that to it. Kind of not sure if I like the FPCs or the actual wires, but this particular FPC is being a pain every time I try and stick the wire in the connector. Okay. Final one. twisted when I closed it down. And this was obviously done with the older driver styles with the wires in mind. Because like I said, I could see a better redesign of this with all of these FPC cables. Oof. Okay, so there's all of our FPC cables. Like I said, we're going to have to figure something out for this. It kind of doesn't look all that pretty right here, but it is what it is. We know we're going to need to get some wiring in here for these two drivers. And we're also going to have our fans that are going to mount right over the top of our drivers like this. So that's what we're going to be doing here. What I need to see is whether this JST here is for the fan or what. Oh, there we go. Yes. For a 12-volt cooling fan, interface can only be connected to 12-volt fan. Oh, there we go. Got our dedicated fan connections right here on these boards. Now, these wires could probably be a lot smaller. Yeah, I'm going to cut these down because we can plug each one of these in, fold it over, and not have as much cable in the way that we have to manage. So I'm going to cut these down and we're going to recrimp these. I do need to these two out, however, because I'm not going to need them. Put some longer M3 screws in from the top down. That little board that you took off on the CRM4 that went to bed. So that would be a external MOSFET. So yeah, give me 1 second. So this would be the way we did it in the old days. So this is actually the board. This is a MKS base 1.4. So this would be what was used on the TiVo Tarantula. Also, very similar board was used on the ANET A8, right? And we all know about the fire issues that we had there. So the issue is you bring power in here, and then this goes out to the bed. Well, these connectors, the physical connector is not rated for a high enough amperage that the bed can draw. So you tend to melt these connectors and cause an internal short. So what we started doing was taking, this is the control on-off wire, plugging that in, screwing that down because this only needs like 3.3 or 5 volt logic to turn this on or off, to do the switching. Then what you have is your DC power in, your DC power out to the bed, and it uses this MOSFET to keep the power circuit and the flow cool, right? So power in, power off, what this is doing is switching on the MOSFET on and off. This is a lot bigger MOSFET. This is a lot smaller MOSFET. These right here are the MOSFETs for the hot end and the always on fans. This was the bigger one for the bed. This is probably sized decently. This is crap, and this is what melted and caught fire. I actually had that on one of my boards, and I removed this and soldered my bed directly to it and came off with an XT60 pigtail. That's initially how I did it, and then I started doing external MOSFET. So a beefier version of this is what you were using for your bed on the CRM4. And the only difference is this is a vertical cooling fan for the MOSFET. So look at the size of this MOSFET versus that one. And you've got all of this cooling wrapped around it. The one that you're doing, or the one that you had, is a different version of this with a horizontally mounted MOSFET and a heatsink more reminiscent of these. And I've got one of those as well. So yeah, that's kind of how that's set up. Six. Okay, so where were we at? We were going to cut these down. And so what I wanted to do is look at, okay, maintenance wise, if I ever need to take this off, I'll undo the 4 screws, kind of lay it over on the side or pick it up so that I can get to these. So I really only need about that much to comfortably do these. So what I'm going to do is I'm just going to cut these off, and I'll come back and re-terminate these. They're just standard JSTs, so got these all to approximately the same length. Now, I've got 4 pigtails. Don't throw these away. Put them in a knot, keep them. You can use these for other things. Hey, Big Jano, how's it going? You're going to ask a dumb question. What do the separate MOSFETs provide here? So the separate MOSFETs that I showed just a couple of seconds ago were separate MOSFETs that I used on an old 8-bit board for my TiVo Tarantula, right? What that's doing is providing I'm sorry, I'm going to have to sit down, so give me 1 second. it's providing a larger cooling surface and a larger MOSFET to dissipate the heat. On those older boards, what would happen is either the MOSFET on the board was undersized or inappropriately sized, or the connector, so the physical connector that was used was not properly rated for the current. So you would have a connector that would go up, cause an arc that would blow a MOSFET on the board, and then you were stuck. So you use an external MOSFET. These are actually external 5160 drivers. So rather than normal step sticks here, we're using basically boards and then FPC connectors that move the correct pins over onto this board. And then what we're going to do here is power in, power out, and then the 4 wires that go to the motor. So we're going to supply 24 volts to the board that's going to run our Z and E motor, or the stepper. We'll have Z and E here, standard TMC 2209s. And then we're going to be running 48 volt to the bigger external 5160. And we're just using FPC cable versus like a standard like jumper wire like this setup. Either way, we're going to have cable that's just kind of too long. At least with the wires, you can kind of wrap them up and zip tie them out of the way. You don't really want to do that with FPC cables because you put too much of a kink or a bend on them and you break one of those internal cables and you're having a bad day, right? So now what I'm doing is each one of these drivers actually comes or enables a 12 volt cooling fan to be directly connected via JST connector to the board. So all I need to do is I just trim these wires down and I'm going to re-terminate JSTs so that we can mount this and just get away with a lot of wiring. We don't have a lot of space for wiring is where I'm at here. So I'm just going to try and get rid of some of the wiring. So I've got pigtails that I can use later. I just need... actually, I've got JSTs with JSTs, but these are a different size. These are those Moschinus. I was going to be cutting those connectors off anyhow because they use a different size JST. At least now I know why they put JST pins in. These are the somewhat smaller JSTs. Yeah, so what it is these are going to be being supplied with 48 volts. So these 4 drivers are X1 or X1, Y, Y1. So we've got 2 motors for each X and Y, the all-wheel drive. And so when you're supplying 48 volts and it's 48 volts with 350 watt power supply, and it's the only thing that's getting the 48 volts. So we're basically going to be able to push these at well over an amp each. So, yeah. Now, hopefully, you don't hear me start cussing under my breath over these little connectors. So I have a hate-hate relationship with these things. And welcome on in, Royal Nomi. I saw you sneak in over there. By the way, Big Jano, how are you doing tonight, my friend? It's been a while. It's been a minute or two. Mixture, but the numbness is more annoying. So I am hearing all of my machines are silent. Little scary. Doesn't happen that. But I know at least one of them I'm going to need some more parts off of. So give me 1 second. There's the other static side skirt blowers. So that means I got both of those printed, and I need to print some more mounts. So that's why I need to get this pulled off. The hour-and-a-half print and then the 2.5-hour print. Okay. Get back to doing finicky, tiny little connectors. Back. You're doing some Octoprint? Wheat? I've been doing board stuff. So we've got our external drivers connected up with all their FPC ribbon cables. Not 100% sure if I like those over the standard cables, but is what it is. I have definitely like I try not to mix and match, right? So with this being a kit that has all mellow in it, like if I ever decided to say go CAN bus to the tool head board, something like that, I would get a Mellow Fly 36 CAN bus board, right? I would not grab one of my Big Tree Tech CAN bus boards because I don't want to mix vendors. There shouldn't be an issue, but I don't want to cross those vendor lines on a build because you kind of get into some weird territory. Like right now, this is even this build, the 5160 drivers that are being provided in the kit, version 1.5. You know, these drivers are version 1.5. It's not in the online Mellow documentation. So it's kind of one of those things of how do you properly account for and or cross different vendor products if you don't even have good documentation. I'm gonna have to cut these off just to keep them at the same length because apparently when that's the other thing with these smaller connectors. If you give it just the slightest amount of ugga dugga too much, you wind up cutting the wire and cut right through the insulation, and then you're winding up starting over again. Glad that they gave me some extras. However, I also have some extras in a different kit if I do. Finally got the one artillery to print pretty. Need to measure with the other one. No, that's measure. You're right. You need to measure. Figure out what box to put it back in to ship it to somebody else, or make sure that it meets the guidelines for disposal and the because I do understand every once in a while, Royal Nomi, you gotta threaten them sometimes. They're being cantankerous and not listening. And I tell you what, yesterday and today must be a day for cats because Frankie was all kinds of vocal on your stream last night. To the point I was trying to figure out, like, did you piss him off? Did you kick his girlfriend out? Or what happened? And then another person that I follow on Twitter, her cat scratched her on the face today. I had to ask her, like, okay, what'd you do to piss Nori off? 'Cause that's normal Frankie mode. I don't remember him being that vocal, but okay. It has been a minute since because I haven't been on people's streams as much lately. sure your little fiddly wires seat appropriately, because if they don't and they come out, no need sparkies, right? No sparkies, no fans that don't go burr or blow when they need to, causing things to get too hot. So your brother has fairly old Elegoo Neptune 2 that needs some work. Thinking about something I saw where the guy put a Voron stealth burner on an ender. Think you can do this? I've got no experience with the Elegoo Neptune 2. If it is a very similar to an ender, then yes, I have seen we'll say the mounts or adapters that will allow you to put an afterburner or stealth burner on a Ender 3. So if there is an adapter, a mounting plate for that, then I don't see why that would not work. I know if Zombie was here, he could probably tell you. Well, I mean, if there was a mount for a stealth burner, that wouldn't be bad, and it would probably be enable you to use the full like PLO style induction probe, which, by the way, any of your tool heads like that, like anything that you can put a stealth burner on, the new Big Tree Tech Eddy probe is the same size as the standard PLO probe, so it's a drop-in replacement. So, saying there's some options. But I will also say that I had mounted a Sherpa Mini to my Ender 3, running a Sherpa Mini extruder with a microsys all metal hot end in it. So there are definitely options out there. Shenanigans, are you still out there listening? I know you're working, which I think means driving. So if you're driving, no worries. I was just going to ask you if you were still working on that project, if you had looked at the Revo Roto a little bit more and whether or not that was going to work in the design or not. Because Revo Roto is a pretty compact little setup, and I don't know if you saw that or not, but LDO just announced that they're going to have boards, toolhead boards for the Orbiter 2 and the Orbiter 3. There's a roto board for Duet. And if they're doing boards for an Orbiter 2 and 3, I am almost positive that Jason probably has one in the works for the Revo Roto as well. I don't know for a fact, but it would not surprise me if one of those doesn't get announced. Okay, Royal Nomi, I'm not sure why you're getting yelled at for being out of bed. But take care of yourself. Please. Okay. So we've got all of our fan pins or fans redone, so we can install these. You know what I was just looking at is with this on, you're not going to be able to get to any of these connections through down terminals. So I'm going to say I'm glad that I got this prepped. But we're going to leave the fan setup off to the side because it makes no sense to put it on, only if I may wind up having to take it off again later. So do like that. Okay, so we've got that part set and ready to go. What else do we need to do here? Back to our video. Starting to do the actual mounting. So we got, just to recap what we did, we've got our board physically mounted. We got our 4 fuses, blade fuses installed, 15, 10, 15, and 15. We got our 5 little replaceable MOSFET boards installed for our fans. We've got our 4 driver boards installed with the FPCs to connect over to the 5160 drivers. These are all set and jumpered in SPI mode. And then we've got our TMC2209s. These are configured for UART mode. The spare 2 jumper, or the spare 2 motor sockets, the third position here is also in UART mode. These first 3 will take 24 volt power. This one on back is set in SPI mode. These would be able to take from the high voltage. So we could, if we wanted, put a higher voltage in here, but these capacitors won't take it. So what we're going to be doing is running 24 volts to all positions, and then bringing 48 volts into these 5160 drivers. Now we need to work on the actual printer, I believe. So let me scoot these boxes over here to the side. Go ahead and put the rest of these. We'll probably use these fork connectors when we do the actual wiring up of things. So possibly later tonight. If not, then definitely on the next stream. We do have plenty of JST connectors for doing things and installing stuff on the board if we need to. That stuff over there, these are empty. I'll see if Mrs. Dragon wants them, and if not, they'll go in the garbage. This one has the leftovers from our board, so leave that over there. This connector is interesting. So Vez was talking about plugging this cable in and then using this to power the Raspberry Pi. This is a CAN bus USB adapter. I don't think we'll be powering the Pi using this. I think what he did was pulled the 5-volt from this CAN connector to run the Pi Pi over the 5-volt GPIO pins. My plan is, and this is where I will mix things, is because I may run a Big Tree Tech Pi board, which can put 12 or 24 volt directly in to power that board. So hey, Westry, how's it going? Uh-oh, bot. What we got? Associated DMH. Hello, sorry for bothering you. Want to promote your channel? No, thank you. I don't need your promotion. I do not have a bot for that, but I can. Over here, since I don't have a moderator. Fine. At least he's banned. That kicks him. Yep. I really don't like people that jump in, follow, and immediately start trying to spam Fred like that. So thank you for calling that out, shenanigans. You got it going via Octoprint and then it failed. Now, did it fail or did it fail because of Octoprint shutting down, or did it fail due to a nozzle clogger issue? Okay, cool. Bed adhesion. Gotcha. So if you're having a bed adhesion issue, then yes, I would suggest some Vision Miner nanopolymer. Works great. I've actually been applying it to a lot of my beds lately. My printer print bed, not my bed. No need for it on the bed. Okay, so we've gotten cleaned up. We've got our board kind of there. What he's getting ready to do is drill and mount the power supplies. Sorry. Which we had already done on our last stream. right? We've got our two power supplies. Let me hide this for the moment. We got our two power supplies on. And what we're going to need to do is get our DIN rails mounted. Well, there was no holes for mounting DIN rail. There are some holes there now, but that is because Steve Peterson, aka Steve Builds, provided some jigs. So what I did, this is going to be the same regardless of which side. So you take your power supplies off and you take the bottom panels off, and this gets lined up with the edge and with the hole for the top of your power supply. No, not the power supply. I'm sorry. The side mounting hole. So this hole right here, take this, you set it up and you line that right over the top of that hole. Then you mark the hole that's in the end here. I couldn't get my fine tip Sharpie through there, so I took a 2mm drill through that and then made a hole. Similar things with the bottoms, except there's one of these and you just have to put it on there and mirror it. So you get one for each side, and visualizing that this is the bottom corner here. You've got a raised edge that allows you to put this in the corner of the panel, and then mark for your two lower holes. So I did that. I marked them, and I used my spring-loaded center punch them. I drilled the holes to 2mm and then drilled them to 4mm. And what that will do is that will allow me to put a 4mm screw and use 4mm nuts to hold those in place. And I just realized that I only have two 4mm nuts left. The other thing that you could do, if you didn't actually drill your hole to a full 4mm, if you drilled it to like 3.5, is you could tap this 3mm aluminum sheet directly for a 4mm hole and screw directly through your piece and yeah, screw it directly into the back panel. And that's what I did on the Annex Engineering K3, right? So that is an option that you could do as well, is to tap and screw that directly in. Now the issue I have is now I need to find some M4 nuts, because I did not check that I had M4 nuts. And I'm going to need some M4 nuts to actually hold my pieces in. Give me half a second here while I look for some M4 hardware. think well, I've got two M4 nuts to go with the other two M4 nuts that I have in the kit, and I will order some M4 nuts. So, and an M4 by 6, which was the screws I was using before, would give me about 2 millimeters of engagement. May not be enough. And, oh, those are locked nuts. Sweet. There's some M4 by 10s. Maybe somewhat long. Double check and see if the M4 by 6s that I had, if they will engage enough. If not, oh wait, these are 8s, but they're not button head. I need button. We'll check and see if our M4 by 6s are enough. And if they're not, then we'll figure something else out. There's a M4 by 6. That should get us that would be enough. We're not looking for a huge amount of strength here. Like I said, we could very well have tapped these holes, drilled them at like 3.5 millimeters and tapped those holes, and then just screwed directly into, from this side into the panel, and been perfectly fine. So there's the first one. We'll put some Ugga Dugga behind it. So grab the driver. Pliers. I've done that before. And doing it this way, yes, we've got the nuts here. It shouldn't matter. We shouldn't be that close to the sides. And we don't want to do anything right in the middle, because then we'll be right where that V logo is. And we don't want to cover up the V logo. Right? That would just be not cool. It's a pretty cool little Vez logo. So we'll try and keep that visible as much as possible. I'm going to have to buy some more M4 nuts. Probably something, as I do some more of these builds, I'm going to wind up needing, because VzBot used a lot. And this is using a lot. An M4x8 would work here as well. When I drilled these holes, I did make sure to, I didn't ream them, but after drilling them, I did go in and clean off any burrs on both sides using my deburring tool. And I might have to come back and replace this one lock nut with a standard nut, just because the lock nut's not really getting in there for much of a good bite. So let me put this stuff back. Okay, so we've got our den rails mounted. Now he was showing two short stubs over here. If we cut this, then we would need to add, you know, two more holes down here. It's lower in the build plate or in the build volume of the printer. You probably wouldn't notice it as much. We're using, you know, screws that don't necessarily detract from the appearance. So that's not bad. Knock this over. I'm going to get this out of the way. Okay. So now we need to go ahead and start setting up our electronics area. He's going to talk about drilling the holes here, kind of showing how things would lay out. Sorry, turn this back on so you'll see the layout. So it's kind of showing your SSR down here, your mains on one side, your DC on the other, and then your controller up here. What I'm looking at is doing something like this, where we've got 5 volt, 24 volt, 48 volt. I don't know if I'll need the 5 volt or use it. Right now I'm going to use the 24 volt and the 48 volt, and I might just have a common ground or set of grounds down here. But this would get like mounted on one side. I'll have another one with the same breakout, same thing, just labeled ground, line, neutral. And that'll go on this side, and this will be the mains voltage quadrant, and this will be the DC quadrant. And with the ground, neutral, or ground, line, and neutral, I'm going to put the Wagos at the bottom so that all of the connections are 110 down here, except for the stuff going to the bed and the thing coming from the Z, right? So we're just trying to segregate and segment out the voltage that'll kill you from the DC that's just going to sting and annoy you. So we need to put our den mounts on. And for these, I'm going to use M3x8s. Mount those. By mount them, I mean I need to put the dang clips on there. Still need to break these free because still not, springs still aren't breaking free. Don't know why. I know why. I think I've got, my bed is just a tiny bit too low. So I'm getting some elephant's foot. There we go. Causes issues on a print and place spring. Oh, I like these print and place skin spring clips. They're pretty low profile, so they don't stick up as much. Make sure that you put them in the right orientation that you want to use them. These might even be better with flathead screws if I have any. So let me see if I've got, rather than button head, flathead. I think I do. M3 flathead. Got some M3x6s here. Let's see if those will work. And make sure you put your springs in the same direction. Not that I would ever put my spring brackets in opposite directions when you're putting two into an item. Once again, this is the 5, 24, and 48. Before we actually mount it, let's grab our Wegos. And this stuff is not in the kits. Grabbing from my stash. Or at least I don't remember them in the kit. So I'm going to go ahead and populate the 24 volt and the 48 volt because I know I'm going to be using those. And normally on something like this, I would do, well, there's one of two options. Like we could do these. So I had the option of doing this, or I could do the ones that look like this style. Okay, so you'd have your positive on the top, negative on the bottom, and you could do a separate one for 48 volt, 5 volt, 24 volt, what have you. That's another option that I may still go with. I may swap this out and go with this because that way I can keep the 48 volt and the ground together. Though it did say to run a common ground between the PSUs on the DC side, so, or at least the voltages. So it was talking about using a common ground, in which case you could basically take your put a 5 here and a 5 here, and all I need to do is jumper these two together. That makes one common bus bar for ground. I don't know if I'm going to need 5 volts, so I'm not going to bother putting a Wago in there yet because why populate if I don't need it? I will need at least one ground rail in here. And like I said, if I need to, I can extend it by doing another ground under the 48. Actually, I can either daisy chain all of the grounds or I can run separate grounds. I don't know what's the best. I don't know what's really the best for those drivers, whether it would be to daisy chain them all together or running separate grounds to each one of the 5160. So that goes there. This will come here. We will move it closer to the side here. Actually, how's he showing? He's showing it more centered with cable trough. Dang it. Yeah. So he's got one long cable trough underneath. He shows one here. I have no idea why you would put one down here, unless it's to technically bring your 110 and go down. But I'm going to prop my 110 right here. And then it's going to go from here to the 110, back to this side, and then one that runs over to this one. So I don't know if we'll see. We'll see if I want to try and put one down here. There's no real nice way of doing it. We'll kind of bring this up, center it. Okay, so that's what I'm seeing is his board is slightly different than the layout of mine. Yeah, it's whatever this piece here is would be like a wireless controller. is this is a board-to-board connector set here for probably a wireless module. So we take this. Oh, come on. Connectors into place. Seriously? These DIN connectors may be pretty darn tight. Oh, there we go. Got them both. All right, so there's our main board. I think what I'll do is as we start laying some more things in here, we'll lay out the cable trough, just kind of check some things out. It's showing a full thing of cable trough going here. It's actually two separate pieces with a full lid on it. Is the way he did his, because he has one continuous piece of conduit here. But yeah. So DC's over here. I've got the high voltage printed as well. And there are various DIN mounts that you can use for these to get these to work. Once again, this is just one that I did and added letters to for ground, load, and NTRL for neutral. I've known people that have either used the color-coded connectors or have printed each one of these as a separate thing and printed them in different colors. I mean, there's options, folks. There's options. So let me get some heat set inserts into this one or these two, and we'll get this mounted. And we may be calling it a stream after getting this mounted. 9 o'clock, and kind of got a lot going on, so get that mounted. Maybe we'll do a couple more. There's another couple of things we can without too much fuss. Or at least I believe there is, provided that he provided that the right wiring. Uh-oh. Last day of school is tomorrow, and you have a Spanish final, and you've been working on 3D printers. What's up with that, dude? I'm just giving you a hard time. You get out at 10 o'clock tomorrow. So, oh yeah, I remember those days. I remember those days. So for those of you that have been sticking around and those of you that that are newly joined, one of the things that I made comment of at the beginning of the stream was I've got some packages arriving tomorrow. Those packages, of which there should be 3, are my Mellow Mini Mill, which is coming in from KB3D. I purchased it. It's not a sponsored build, but we will be doing a Mellow Mini Mill on stream. Chances are it is not going to even get started. I'm not even thinking about getting it out of the box before Midwest Rep Rap Festival, just because there's so much stuff going on between now and then. And I need to focus on getting stuff done that I need to get done for that show, such as this build and Black Box, and still trying to get some signage done and stuff like that. So we may kind of look through it and do an unboxing. I haven't decided if I'm going to do that yet, but yeah, got our Milo. And this is a batch 2, which means it's coming with the spindle. I got the 110 volt spindle. I figure if for any reason that proves not to be enough and I need to actually go to the 220 or the 220, 230 volt spindle, that I could always take the 110 and go mount it on my Shapeoko out in the shed and run the Shapeoko on a spindle versus a Makita, basically is what it is. It's the carbide router, but it's basically looks, smells, and feels like a Makita. I need to figure out my air height there. Hey, Steven, welcome on in. How are you doing, my friend? In Talon, good to see it. You're still here. Doing this, I'm doing what? Oh, blue as always. I think I'm close enough. Get a couple more of my M3x6 countersunk screws. Well, it's random as far as the drop game goes. It's just random. And I don't have mine on hard. Some people have theirs set on like hard or extra hard, and it gets like really, really whipping crazy. And like I said, for our whatchamacallit, for our mains voltage, I want to make sure that all of my connectors are facing down towards the bottom of the printer so that I can route them into an appropriate spot, whether it's into a cable channel or into some wire wrap or something to keep it neat, but keep it out of the way. We've got all of our Wagos in at the bottom side of this. And fight the springs again. Thought I had working. Apparently they weren't fully working yet. Oh, gee. One side's working, the other side still isn't. Righty. So I just broke that piece. So we will be holding off on mounting this for the moment since I just broke a piece, and I'm going to have to reprint a spring mount or a spring spring whatever. I need to print them out. So redo that. We can go ahead and put in our whatchamacallit. And I'm going to put it in so the words are upside down because the load is at the bottom here, or is it this side? The input is at this side. So by putting it in that orientation, once again, my high voltage is facing down, which I want all of my high voltage running across the bottom because I need to run the load, neutral, and ground to the pins on this side. Bring them down, come across to my Wagos over here. This will have the load and the power and the load on this side. So that's how we're going to do that. We do have a whatchamacallit, a power, and you give me the black and the red wire to do the jumper between the switch. I guess they do give me the other wire. I'm confused now, which is nothing new, but so in the bag or in the box that had the power switch, we've got two small jumpers, and these would normally be your between the, for the fuse between the switch and the actual inlet, and then you would have a ground. Normally, these are not blue and black. Also, these are blue and black with spades at each end, which makes no sense. So, may not be using this one. Also, .6 millimeter squared wire. I mean, should be fine for the jumper wires and stuff. But once again, I'm not used to using this. Not red and black at least. You can, but normally that's not the wire scheme that's used. So we'll hold off at that point. I think we're going to call the stream, and we'll come back and we'll continue to work on this stuff. I'm trying to see, okay, this was the, whatchamacallit, the CPAP. So cute. That's our little CPAP controller. This was the cables. Cables. Okay, I think that's it for where we're at today. We will be back to this on Thursday. I'm going to reprint one of the DIN mounts that I snapped the V off of. And we will come back and get this going again on the next stream. We may, who knows, I may change some DIN mounts. You never know. Different ones, but yeah. So let's see who is up and running at the moment that we can raid out to. Or if anybody has a suggestion, the maker deck, declarations, the game. Okay, Andrea, game, Chris Perillo, Vegan, Ross is Dina Moore. Astro up and running, gangs, brick building. DNA has a birthday stream going on. Babe Ross, Bezliz? We can do that. All right, Tugboat, have fun. Hey, go study for your final, dude. Go study for your final. Don't use me as an excuse to not do well on your final. Babe Ross? Yeah, we can do Babe Ross. We can do Babe Ross. All right, so raid started for Babe Ross. Please go ahead and join me as we head on over to Babe Ross. Say hi, share the love, and we will come back Thursday and continue working on the electronics here. As you can see, we're having to kind of muddle through it a little bit because the documentation is wide open on this particular point. So thanks a lot for being here, everybody. And we'll be here on Thursday to get some more progress done. And who knows, maybe we'll be doing some hot sauce. Stupid. Take care, everybody. See you then. Have a good day.